This is a training module on the DS28EA00 one-wire digital thermometer made by Maxim. Welcome to the training module on the Maxim DS28EA00 one-wire digital thermometer. This training module introduces the DS28EA00 digital thermal sensors and its internal operations. The DS28EA00 is a one-wire digital temperature sensor with plus and minus a half a degree C accuracy and a new chain mode signaling and protocol feature that quickly and automatically determines the physical location of individual sensors in an environment where multiple sensors are connected to a common one-wire line. The DS28EA00 measures temperatures over the minus 40 degrees C to 85 degrees C range and has user programmable analog to digital conversion resolution with 9-bit to 12-bit options. It operates over the Maxim's one-wire interface with a protocol that delivers power as well as communication over a single connection. Hence, it has a unique 64-bit internal serial number that is used in a multi-drop environment to select a specific device for temperature results. The DS28EA00 is ideal for applications that require accurate multi-point digital temperature measurements with minimal wiring complexity and cost. Typical applications include rack-based equipment such as wireless base stations, central office switches, enterprise service, HVAC, and process monitoring where accurate multi-point temperature sensing is important for system reliability. The block diagram shows the relationship between the major functional blocks of the DS28EA00. The device has three main data components: a 64-bit registration number, 64-bit scratch pad, and alarm and configuration registers. The one-wire ROM function control unit processes the ROM function commands that allow the device to function in a networked environment. The device function control unit implements the device-specific control functions such as read-write, temperature conversion, setting the chain state for sequence detection, and PIO access. The CRC generator assists the master verifying data integrity when reading temperatures and memory data. In the sequence detect process, PIOB functions as an input, while PIOA provides the connection to the next device. The power supply sensor allows the master to remotely read whether the DS28EA00 has local power available. The basis of one-wire technology is a serial protocol using a single data line plus ground reference for communication. A one-wire master initiates and controls the communication with one or more one-wire slave devices on the one-wire bus. In all instances, the DS28EA00 is a slave device. The bus master is typically a microcontroller. The one-wire port of the DS28EA00 is open drain with an internal circuit equivalent to that shown in the figure. The DS28EA00 supports both a standard and overdrive communication speed of 15.3 kilobits per second max and 125 kilobits per second max respectively. The idle state for the one-wire bus is high. If for any reason a transaction needs to be suspended, the bus must be left in the idle state if the transaction is to resume. All transactions on the one-wire bus begin with an initialization sequence. The initialization sequence consists of a reset pulse transmitted by the bus master, followed by a presence pulse transmitted by the slaves. The present pulse lets the bus master know that the DS28EA00 is on the bus and ready to operate. Once the busmaster has detected a presence, it can issue one of 8 ROM function commands that the DS28EA00 supports. All ROM function commands are 8 bits long. These commands include read ROM, match ROM, search ROM, conditional search ROM, conditional read ROM, skip ROM, overdrive skip ROM, and overdrive match ROM. The control function command determines the device necessary for measuring temperatures, accessing the memory and PIOs, and changing the chain state. Finally, the data transactions start in terms of different commands during specific time slots. The DS28EA00 requires strict protocols to ensure data integrity. The protocol consists of 4 types of signaling on one line: reset sequence with reset pulse and present pulse, write 0, write 1, and read data. Except for the present pulse, the busmaster initiates all falling edges to get from idle to active. The voltage on the one-wire line needs to fall from VPUP below the threshold VTL. To get from active to idle, the voltage needs to rise from VIL max past the threshold VTH. Data communication with the DS28EA00 takes place in time slots, which carry a single bit each. Write time slots transport data from busmaster to slave. Read time slots transfer data from slave to master. Each PIO consists of an open drain pull-down transistor and an input path to read the pin state. The transistor is controlled by the PIO output latch as shown in the figure. The device function control unit connects the PIOs logically to the one-wire interface. PIO-A has a pull-up path to internal VDD to facilitate the sequence detect function in conjunction with the chain command. PIO-B is truly an open drain structure. The power on default state of the PIO output transistor is off. High impedance on-chip resistors, not shown in the graphic, pull the PIO pins to internal VDD. The chain function is a feature that allows the one-wire master to discover the physical sequence of devices that are wired as a linear network. This is particularly convenient for devices that are installed at equal spacing along the long cable. Example, to measure temperatures at different locations inside a storage tower or tank. Without chain function, the master needs a lookup table to correlate registration numbers to the physical location. The chain function requires 2 pins, an input, enable, to enable device to respond during the discovery, and an output, done, to inform the next device in the chain that the discovery of its neighbor is done. The 2 general purpose ports of the DS28EA00 are reused for the chain function. PIO-B functions as an enable input, and PIO-A generates the done signal, which is connected to the enable input of the next device. Precise and adaptable thermal management is imperative for efficiently managing the energy consumption of data centers. The ambient temperature in a data center or other thermally controlled environment is not constant throughout the space. Temperature varies significantly across the vertical and horizontal planes, depending on proximity to active or inactive equipment, as well as airflow. The ability to identify specific areas where ambient temperature needs to be reduced is the key to reducing data center power consumption. Multiple temperature measurement nodes, combined with appropriate temperature data processing, enable an optimized environmental temperature control system that saves power and reduces costs. The one-wire interface can solve the wiring complexity challenge of large multi-point temperature sensing arrays. Using the DS28EA00 chain mode function, the one-wire master reads and associates the sensor's registration numbers according to each device's physical location in a multi-drop configured connection.